see my screen? Okay, very good. Now let's start today's class. Today we'll start to learn chapter 11. This chapter will focus on special factorizations. Actually, we already learned this one before, but here we will try to extend the application of factorizations. In the previous chapter, we use factorizations to solve the quadratic equations. Actually, factorizations has more wide applications. Not only you can use to solve the quadratic equations, you can use it to solve a lot of other problems. And also, we could see these examples. Okay, so if you expanded the product of binomials, then you can get a quadratic, right? Then if you reverse that process, then you have to do factorizations. If you can factorization of a quadratic, then you can get the product of two binomials. Now let's see first this example, 11.1. Expanded each of following. So everybody, can you send me your answer for this A? Expanded y plus 5 parentheses square. Then let me check if you can get the correct answer for this. Okay, Lucy got correct, but Lucy, usually we prefer write the terms start from the highest order to the lowest order. So that means you need to put your linear term to the middle. Yes, like that. Yeah, very good. Okay, Andy also got correct. Who else? Okay, Jasmine and Lily also send me your answer. Is this should be? We already finished this. Lily, you mean we already finished this section? 11.1a. Yeah, 11.1a. This one is for 11.1a. You don't need to set that one yet because we have not finished this one. Then, okay, let me write down this answer for A. This one equals y squared plus 10 times y, then plus 25. Okay, very good. Now, let's everybody send me answer for B. Andy, now check Andy's answer. Andy's answer, that's right. Lily, you miss one term for, when you expanded the product of two binomials, usually you get three terms. If you write two, you miss the linear term. So the correct answer for this B, that equals 9z squared plus 48z, then plus 64. Okay. Lucy, you have some typo there. Yeah, 9z squared plus 48z plus 64. Yeah, now that's correct. Okay. So now let's see, take a look at your result. What are some clues that each expanded quadratic can be written as the square of a binomial? So they try to ask you find this formula like x plus y square if we have a here, okay? This one will equals a square times x square plus 2a xy, then plus y square, okay? This one is formula. Actually, this one it's extended formula of this one. Okay, this one equals x squared plus 2 times x times y, then plus y squared. Okay. Now let's move to example 11.2. Expand each of following: x minus 6 princess square. Everybody send me this answer. See, this one is very easy, okay? You can write this one as x squared minus 12x, then plus 36, right? Then now let's move to b. If you extended this one, see what you got. You got a 4y squared minus 36y, then plus 81. Okay? Say they ask you take a good look at your result. What are some clues that each expanded quadratic can be written by the product square of a binomial? Okay, so then now let's go to example 11.3. So this problem, they ask you to do the reversal process. For each of following, state if the expression is a square of binomial. If yes, then factor the expression. Now let's first do A. Is this one, it's a square of binomial? Okay. Notice you're right. Then you need to write. What is that? Yes. Okay, very good. This one you can write, this one is x minus 3 princess square. Okay, very good. Now let's move to B. Is this one, it's a square of a binomial? Right, this one is no. You cannot write this one as a square of binomial. Okay, now let's move to C. Is this one you can write square of binomial? C. Okay, this one, the answer is also no. Okay, how about this one? D. So then write your answer for this. That'll be x plus 1/2 princess square. Okay, good. Then now let's move to E. No, it's not. Okay, this one no. Okay. Now let's move to F. Is this one you can factor in? If yes, write down your factorization. So this one, let's try 2y minus 7 times z, then princess square. So this one, yes. we can write this one as 2y minus 7z parentheses square. Okay, very good. Now let's see example 11.4. If x equals 6 over 7 square root, then evaluate x plus 1 over x parentheses square. Okay, so everybody, I give you 1 minute. Try to solve this problem. Send me your answer in private chat. Don't talk. Okay, actually you have 2 ways to solve this problem. One way, you can expand this square of binomial. You can get a x squared plus 2, then plus 1 over x squared. So then we can plug in x, so this one will equal 6 over 7 plus 2, then plus 7 over 6. So then you can write this one, it's 42. This is common factor, right? Then this one equals 36, then plus 84, then plus 49. Then now let's add this together. 36 plus 84, that's 120. So that will be 169 over 42. So then you need to check if this one is already in the simplest form. So 7 digits, 7 plus 9, 16. So looks like, oh yeah, looks like we still can simplify. 13 times 13 equals 169. 9 says 3, 169. So this one you can write 13 times 13. Then 42 equals, can we do times 4? No, this is not 4. 13, we cannot divide this one.
Why is it 13?
That will be 14 times 3, right? So that means we cannot simplify. So this one is already the simplest form. So that means we cannot simplify this. This one is the correct answer. Okay? So Andy got this one correct. Very good. So now let's move to example 11.5. Say this problem, they ask you calculate this expression in 2 ways. First way, factor the expression. Okay? So you can consider this one is a variable. This one is another variable. Then you can factor this one, because this actually, if you think this one is x, this one is y. So this first, that's x squared. This one is x squared minus 2 times x times y, then plus y squared. So that means you can factor this one as x minus y parentheses squared. So that's 20062,005 minus 2006,2003, then parentheses square, right? So this one, minus this one equals 2. So this one equals 2 squared. So this one gives you 4. Answer is 4. This one we use factor the expression, right? This is first method. Now let's try second method. This one they ask you let x equals one of the numbers help simplify the expression. Okay, now let's set x equals this number. Okay, then this number will equals x plus 2. This one will equals x plus 2, right? So this one is x plus 2. This one is x. So then we can expand this one, get x plus 2 parentheses square minus 2 times x plus 2 times x, then plus x squared. So then let's say these two terms we can take x plus 2 together. Take x plus 2 out. So you got this left, that will be x plus 2 minus 2x. So then plus x squared. Right? This one equals this, equals this. So then we continue simplify. So this one's x plus 2, then times 2 minus x, right? Then plus x squared. So say first term, you can write this one 2 plus x. Switch order, this does not matter because this is addition. Then times 2 minus x plus x squared. So this one, first this one that's equals 2 squared minus x squared, then plus x squared. So x squared comes out. This one positive, this one's negative. So we only have 2 squared left, that's equals 4. So two ways, we got the same answer, right? But this one, which one is better? Depend on if you familiar this formula, the x squared minus 2xy plus y squared equals x minus y parentheses squared. If you really familiar this, after you see this, you can use a first method. Okay, if you not familiar that formula, you can use second method. You can set this smaller number as x, then do this substitution, then simplify this expression, then you still get the same answer. Now let's move to the next example, 11.6. So here they ask you square the following numbers in your head. Don't use your scratch paper. So everybody send me your answer. What is the square of 71? Okay, you do this, right? 70 plus 1, then parentheses square, right? Do this. So 70 squared, that's 4900. Then plus 140, then plus 1. So by this way, you get 5041. Yeah, Andy, you're correct. Lucy, you're also correct. Now let's do.
All of them.
Oh yeah, great. And six. What? Okay, now 65 square. 65 square, you need to think in your mind like this. Then 60, that's 3600. Then plus 2 times this, that will be 600. Then plus 25. So then you got this one, 4,225. Very good. Now 204, this one square, you use 200 plus 4, then square this, you got the 40,000, then plus 1,600, then plus 16. So then this one you got 41616. Yeah, very good. 99, this one you need to use 100 minus 1, then parentheses square. This one give you 10,000 minus 200, then plus 1. So this one equals 9,801. Okay, and you got all of them right. Very good. It's now let's move to problem 11.7. So this one, they ask you to expand it, the product x plus y parentheses q. This is all the, actually it's binomial, the power of binomials. So now let's say this one, you can write this one equals x power 3 plus 3x power 2y, then plus 3xy squared, then plus y cubed. Okay, say this one you got x power 4 plus 4x power 3 y, then plus 6x squared y squared, then plus 4x y cubed, then plus y power 4. So this x power 5 will equals x power 5 plus 5x power 4 times y, then plus 10x power 3 y squared, then plus say this will be 1 5 2, that will be 10. 3 is same, so 10x power 2 y power 3, then plus 5x power y power 4, then plus y power 5. Okay, this last one, that's equals x power 6, then plus 6x power 5 y, then plus 15 x power 4 y squared, then that will be 30 x power 3 y power 3, then plus 15 x power 2 y power 4, then plus 6x power 5, then plus y power 6. Okay.
How is it 30? I thought it was.
Let's see. That would be, say,
I thought it was 20.
6 to 3. That would be 6 times 5 times 4, then divided by 3 times 2 times 1. Yeah, this one is 20, right? So Andy, you mean this one is 20, right?
Yeah.
Yeah, this is 20. Sorry, I read this one wrong. it's 20. So then, now let's see why I can write this one so easily. Because I know this formula, x plus y power n, this one equals, say, if I first write this x power n, then plus n, choose 1, then x power n minus 1, then y power 1, then plus second one n, choose 2, then x power n minus 2, then y squared. Then keep write this last one, that will be y power n. If I write this one in the compact form, that will be like this. That will be n, choose k, then x power n minus k, then times y power k. So then k from 0 to n. So this one is the formula. This sign n, k, this one is a combination formula. That means n square, n factorial times divided by k factorial, then divided by n minus k factorial. This one equals this. Okay, let me give you an example. Say here, let's say when n equals 6, then when n equals 6, when k equals 0, this one, that means we use 6 factorial, then divided by 0 factorial, then divided by 6 minus 0 factorial. So this one equals 1. Because 6 factorial divided by 6 factorial, that's 1. 0 factorial, that's 1. That's give us the coefficient of first term. Then second one, 6 choose 1. So you get this 6 factorial divided by 1 factorial, then times 6 minus 5 factorial. So then you get this one equals 6 minus 1 factorial. So you get this one equals 6 factorial divided by 5 factorial. This one give you 6. Okay, then you keep do this one, you can find all these coefficients. This is one way. Actually, this factor you can also use that's called triangular. So this one, then that means for the when this one equals 1, that will be 1 1. Then that will be 1 2 1, right? So like this one, I need to write this to the middle. So there will be 1 2 1. That will be x plus y squared. Then that will be 1 3 3 1. So its coefficient is like this. Say.
And then it's 1 4 6.
Yeah. Then that will be 1 4 6 4 1. That would be like this. 1 4 6 4 1. So this one's called triangular numbers. You can also do this way. But if you're familiar with the combination formula, you can also use the combinations. Okay, so very good. We already finished this section. Now let's go to next one. See here, we already finished this section. Then this exercise problem. That's your homework. Okay. Now let's go to where's my book? Yeah. Okay, next one. This section will learn the difference of the squares. So that like x squared minus 1 or x squared minus y squared. By this one, we will need to learn to factor in this difference of squares. So everybody, can you try factoring this 11.8a? Can you factor in this? Now let's see. Okay. Then this one will equals x plus 1 times x minus 1. Okay. Now b, that's x plus 2 times x minus 2. Okay. Now let's see c. What's c? X plus 3 times x minus 3. Okay, very good. Now this one, that's a formula x plus y parentheses times x minus y. Okay, this one is a very important formula. If you know this, then you can do all of these problems. Now let's move to 11.9. Factoring this a. Can we factor this? So this one you can write r plus 20 times r minus 20. Because this 400, you can write this one's 20 square. So then you can use this formula, write as r plus 20 parentheses then times r minus 20. Now, second one. First, you can write this first term, that's 2 times t parentheses square minus 11 square. Then you factor this one as 2 times t plus 11, then times 2t minus 11. Okay, very good. Now, next one. How we can do this? Can everybody try to solve this problem? This one, first you need to think if you can take a factor out. Looks like we can take factor 3 out. Because this second number, the sum of digits equals 12. So this number divisible by 3. So this one is r squared minus 449, right? So that's 49. Then you can continue factor this one as r plus 7, then times r minus 7, right? Because 49, you can write 49 7 squared. So then you use this formula. Okay, now let's see how we can do this. This one you can write, this is a z squared, then square, minus 1 square. So first, use this formula. We can write this one is z squared plus 1, then times z squared minus 1. Then you need to check if this one is the final simplest form. So this one we cannot factor anymore. But this one, say, we still can keep factoring this. So we can write this one as z squared plus 1, then times z plus 1 times z minus 1. Okay, so this one, that's a finalist form. Okay, very good. Now let's go to next problem, 11.10. So say we can use this factoring help us to calculate these numbers faster. So if you don't factor, you need to calculate 5 squared, that's 25. Then minus 4 squared, 16. Right? You can get 9. But if you understand, you can write this one as 5 plus 4, then times 5 minus 4. So you got this one equals 9. Right? And this one, you will know this one equals 11. Then this one equals 13. Then this one equals 15. Okay? So the reason, because we know that factorization formula, this x squared minus y squared, this one equals x plus y, parentheses, then times x minus y. If these two numbers, the difference is 1, then this term will be 1. Then this one, the result just equals, you add these two numbers together, that'll give you the answer. So that's the reason why we just immediately can write the answer for this one equals 11, this one's 13, this one's 15. Okay, so you already found that pattern, right? Now let's go to 11. Say in this problem, we found all pairs of positive integers m and n such that m squared is 105 greater than n squared. Okay, to do that, first we write an equation, put the variables on one side and constant on the other side. So that means we can write this equation is m squared minus n squared equals 105. Right? We can write this. Then we can factor it. We can factor in this equation as m plus n times m minus n equals 105. Now see, use possible factorizations of 105 into the product of two numbers with the equation from part B to solve the problem. Say 105, you can write 105 as 5 times 21, right? This is one choice. You can also write this one equals 3 times 35. You can also write this one as, let's write this, let's factor in this, then we can write all of the combinations. If we factor in 105 first, then we can use 5 divided it, then got 21. So then 3, 7. So this one we can write like 3 times 5 times 7. So then by this way, you know, we can get a number of factor. That will be, remember, I told you the formula to calculate number of factor of number that just add their power 1, then time together. Because you have 3 factors, that's 3, 5, 7, their power that's 1. So you just do 1 plus 1 times 1 plus 1 times 1 plus 1. This one will give you 8. So then you know you have 8 factors for 105. That will be, I can write down, that will be 1, then 3, 5, 7, then you combine 3 and 5 together, that's 15, then 3 and 7 together, that's 21, 5 and 7 together, that's 35, then last one, that's 105. Say 1, 2, 3, 4, 5, 6, 7, 8. So then by this way, you can write, say, 3 times 35. You can also write this one 7 times 15, right? You can also write this one equals 1 times 105, right? Now what else? 1 times 105, 3 times 35, 5 times 21, 7 times 15. That's all, right? Now, say you can set m plus n. Definitely m plus n is bigger, right? They said m and n are positive integers, so definitely m plus n is greater than m minus n. So then now let's see, first for this, you have to set m plus n equals 21, then m minus n equals 5. This is the first equation. The second one, you can set m plus n equals 35. Then m minus n equals 3. This second one. Third one, you can write m plus n equals 15. Then m minus n equals 7. Then last one, you can write m plus n equals 105. Then m minus n equals 1. Now let's solve one by one. Solve this one, you can get, say, if we add these two equations together, we get a 2m equals 26. So that means m equals 13. Then n equals 8, right? M equals 8, m equals 13, n equals 8. This is one choice. Answer for this one. Now let's solve the second equation. We got m will add together, that's 38. 38 divided by 2, then got 19. Then n will equals 16. Right? This is the answer for the second equation. For third one, you got m equals 11, n equals 4. Yes, n equals 4. Now let's see this one, m equals 53, right? Then n equals 52. Okay, this is the 4, this is the 52. Okay, so looks like all this answer is fine. Now see, by this way, this actually, it's a hard problem. If you did not meet this kind of problem before, then the steps to do this problem just like this way. Write the variables to the one side, usually write to the left side, make the numbers on the right side, then factor in the variables. Then you also need to factor in the number. then see these combinations, because here the variables are all integers. So then you can solve the all possible equations get from these combinations. Then you can later you need to check if these numbers satisfy the requirement. So each number should be positive and also should be integers. Looks like all these combinations satisfy the requirement. So then we got all these answers. So then now let's go to next problem. This one is 11.12. Say, suppose x equals z minus square root of z squared minus 5 and 5y equals this. Now in this problem, we try to find x when y equals 2/3. Okay, how to do this? To do this, say A, y met the right side of the two equations make us think of the difference of the squares factorization. Because this one z plus this one z minus this, right? So that's the reason if we can do z plus z squared minus 5, this one times z minus z squared minus 5 square root. If we times this one together, we get a z squared minus z squared minus 5. Then you get this one equals 5, right? So by this way, you will get x times 5y will equals 5. So that means x times y will equals 1. Then they give you y equals 2/3. So that means 2/3 times x. We plug this y equals 2/3 to here equals 1. Then we can get x equals 3/2 equals 1.5, right? See, this one looks hard, but if you say, if we can use this formula, multiplying these two expressions together, we get 5. Then we can get the left side, x times 5y will equal this 5. Then we already give us y equals 2/3. Then we can get x equals 3/2. Then they say B, combine the equation in a way that eliminates z. So by doing this way, we eliminate z, right? And use the result to solve the equation. So otherwise, if you have z here, this equation is really hard to solve. But when you use this formula, you can eliminate z. The equation will not have z here. See, you only have x and y here. Then they give you the y. Then you can find the x immediately. After you get the x and y, then you can plug in to any of equation, use x or y. Then suppose we can plug x equals 3/2 here. Then we can solve this equation to get z, because say if x equals 3/2, then this one equals z minus z squared minus 5 square root. So then we can move this, we can write this one like this: z squared minus 5 square root, this one will equal z minus 3/2, right? Then both sides square, we got a z squared minus 5 will equals z squared minus 3z, then plus 9/4, right? This square and this square cancel out. Got this one's 3z equals 5 plus 9 over 4. So this one we got 29 over 4. So both sides divided by 3. We got z equals 29 over 12. So see, by this way we got a x, we also got a z. They give us y, right? So we solved this equation. But if you did not know or use this equation actually is really hard to solve. But when we use this equation, use this formula, we eliminated z. Then we only get the equation with x and y. We already have y, so then we can get x. Then you can plug x back to solve z. You can also plug y back here to solve z. Okay, so this is a 11.13. Now let's see 11.11. Let's see 11.12. Now let's see this 11.13. Say in this problem, we try to calculate this. Looks this one's hard, right? How we can do this? They say without use a calculator. Then to do this, now let's first try to calculate this one. 7 times 5 times 3 times 1 plus 16, then square root. And also do 8 times 6 times 2 times 4 times 2 plus 16 by hand. Okay, so everybody do this. So if you do this one by hand, now let's see, that's 35 times 3, that's 105. This one's 105 plus 16. This one will equals 121 square root. So we got this one equals 11. Yes, and you're right. Now let's see this one. We can calculate, say 4 times 2, 8. 8 times 8, 64. 64 times 6, 24. 384, then plus 16, that's 400. So this one got 20, right? So first one we got 11, second one we got 20. Now let's go to B. Instead of deal with each large numbers like 1998, we write the expression in terms of a variable x, like that x equals 1992. Then how can we write the original expression in terms of x? So if you set this one equals x, this one will be x plus 2. This one will be x plus 4. This one will be x plus 6, right? That will be like this. But this one, if you have this, is this one can simplify? Looks it still cannot simplify, right? It did not help you a lot. Now let's see C. If you set z equals 1995, then now let's say this one will be z minus 1. Okay, this one will be z plus 1. And this one will be z plus 3. And this one will be z minus 3. Okay, say if you can write like this, set z equals 1995. Now this one we can use that formula. We can write this one is z squared minus 1. And this one times this one will equals z squared minus 9, right? Then you can keep extended this one. Now let's see what you get. This one will get z power 4, right, minus 10 z squared, then plus 9, then plus 16. Then this one square root. So then you can continue. This one will be z power 4 minus 10z squared, then plus 25. This one square root, right? Okay. So then you can get this one will equals. Now let's see. This one will equals z squared minus 5. Then this one square, then square root. Because this one, we can write that's the square of a perfect square. We can write it like this: z squared minus 5, then square root. So this one will give you z squared minus 5, right? So then you can, z that's equals 1995. Then you square this one minus 5. That will give you this, right? So then you can calculate this, right? So if you do set this one is x, smallest one, that's would not help you a lot. But if you set the middle number, this middle, that's 1995 as a variable, then you can simplify this one to this. That will be z squared minus 5. Then you can get that one equals this. Okay, so later we will get this. Actually, here we already finished this section. Now let's see what we have left. Let's check. Yeah, see this problem, we got a 4 pair of solutions, right? 55, 53, 52, 19, 16, 13, 8, 11, and 4. We got a 4 pair of system of equations. That's exactly what we get. Now, yeah, see this kind of equation called Diophant equations. This is a very famous branch in the number theory. Okay, it's very interesting. And now let's see this problem. Yeah, we got x equals 3 over 2, y equals 2 over 3. Then we did not solve z. Now let's see this. Later, yeah, we got a 1995 minus 5. To continue to calculate this number, you can do right like 2000 minus 5, then parentheses square. This one 2000 square minus 2 times 2000 times 5 plus 5 square minus 5. So this one will give you 4 million minus 20,000 plus 25 minus 5. Later you got this one. So your homework, that will be 11.2.1. Now let's see, 11.2.6. Now let's try to solve this last one, because we still have a couple of minutes. See this one, we have, they ask you to find x minus y, given this one, and x plus y equals 3. So how we can find x minus y? So this one, I immediately see this. X power 4 minus y power 4 will equals 18 times root 3, right? So then they give us x squared plus y squared equals 6. So this one I can write like x squared plus y squared times x squared minus y squared. Then this one equals 18 root 3. So, this one equals 6. So that means x squared minus y squared equals 3 times root 3. Right? Now they also give us this. So this one we can write like x plus y times x minus y. Then this one equals 3 times root 3. Then x plus y equals 3. So that means x minus y equals root 3. This one's answer, right? See, so time is up. We can stop here. Then everybody, you need to finish all the homework for the X problems we left in this 2 sections we learned today. So we can stop here, everybody.